You have been writing a function since the very first video. Main. Now you get to write your own. A function is a named piece of work. You say what goes in, what comes out, and what happens in between. Go's version is small and strict, and it leaves out two things you may be expecting. Read a function declaration left to right, and it tells you everything. The keyword func says, a function is being declared here. Then its name, greet. Then the parameter list, in brackets. This one takes a single thing called name, which is a string. And then the body, in braces, which is the work it does. Down in main we call it. And it prints, hello Ada. Look hard at the parameter, name string. The type comes after the name, not before it. That is the same rule you saw with variables, and it holds everywhere in Go. Struct fields, results, all of it. The thing first, then its type. One more thing worth knowing. Functions can be declared in any order. Greet is above main here, but below would work just as well. Go has no forward declarations and does not care. To hand something back, you put a type after the parameter list. That second int is the result type. It says, calling this gives you back a whole number. Double of 21 is 42. And because a call is just a value, you can feed one straight into another. Double of 5 is 10, and double of that is 20. There is a rule attached to result types, and the compiler enforces it strictly. If a function declares a result type, every path through it must return something. Leave one branch without a return, and the program will not build. No accidentally falling off the end of a function and getting nothing back. Go simply will not let you write it. Here is a small piece of shorthand you will meet constantly. When two parameters next to each other have the same type, you write the type once, at the end of the run. A comma b int means both a and b are ints. It does not mean a has no type. The second one shows it mixed. Width and height are both float 64s, and then label is a string on its own. It is a small thing, but if you cannot read it fluently, real Go code looks confusing, so read it as, the type at the end of a run belongs to everything in that run. Now a style point, but a really important one, because Go code leans on it heavily. The pattern is called a guard clause. Check the awkward case, return immediately, and get it out of the way. A negative age is not real, so we deal with that and leave. Under 18 is a minor, so we deal with that and leave. And the interesting case, the ordinary one, sits at the bottom, unindented, with nothing wrapped around it. Compare that with the alternative, an if containing an else, containing another if, drifting further and further to the right. Go programmers overwhelmingly prefer the flat version. The eye can run straight down the left-hand edge and see every exit. And you are going to see this exact shape again in the errors module, where the guard is, if error is not nil, return. Two things Go deliberately leaves out, and they will surprise you coming from Python or JavaScript. There are no default arguments. If a function takes two parameters, every call passes two. You cannot make one optional. And there is no overloading. One name, one function. You cannot have a greet that takes a string sitting next to a greet that takes a number. Both of those are choices, not oversights. The payoff is that when you read a call in Go, there is exactly one function it could possibly be going to. No resolution rules, no guessing which overload wins. If you want optional behavior, you either pass a struct of options, or you write a second function with a different name, greet and greet formally. This one is worth internalizing early because it explains a lot of Go's behavior later on. Go passes arguments by value. The function gets its own copy. So bump adds 100 to n and prints 101. That part is not surprising. But back in main, count is still 1, not 101. Bump changed its own private copy, and then that copy was thrown away when the function returned. Main's variable was never touched. Here is the useful way to hold this. A Go function cannot quietly reach out and modify your variable. If you want it to be able to, you have to hand it a pointer, deliberately and visibly, which is exactly what the pointers module is about. 4 things to take away. The shape is func, name, parameters, result type, body, and the type always comes after the name. A comma b int means both of them are ints. Read that fluently. Handle the awkward cases first with guard clauses, and leave the real work unindented at the bottom. And arguments are copies. Without a pointer, a function cannot change anything of yours. That is the whole of function declaration in Go. Your turn. Write a function called perimeter that takes a width and a height, both whole numbers, and gives back 2 times the width plus the height. Then print it for a rectangle 3 by 5. Pause and write it. Here is the answer. Width and height are both ints, so we use the shared type shorthand and write int once. The result type is int, and the return gives back 2 times 3 plus 5, which is 16. Small function, but every piece of the shape we just covered is in it. That is how you declare a function in Go. Next up is the thing that makes Go functions genuinely different from most languages. They can hand back more than one value. And that single decision shapes how every Go program you will ever read handles failure.